Question 7. An event A will occur with probability 0.5, 50%. An event B will occur with probability 0.6, so 60%. The probability that both A and B will occur is 0.1, so 10%. Okay. All right, there's 5 statements. I guess we are picking the one that's true. All right, I guess there probably is a formula that we could use, but I'm going to try to answer this question with one of my favorite graphic organizers, the two-way table. Okay, so event A occurs or it does not. Event B occurs or it does not. Then we need to include some space for the totals. Okay, so overall, right, this two-way table has to account for all possible outcomes, so 100%. And then we know that A occurs with probability 0.5. Okay, so A has an overall probability of 0.5, meaning it does not occur the other 50% of the time. Event B occurs with probability 0.6. So the total probability for B is 0.6, meaning it does not occur 40% of the time. Lastly, both A and B occur 10% of the time, so that's the first cell here, 0.1, 10%. Okay. So now that we've filled in those values, it's just mental math, some subtraction to find the remaining values. So the second cell will be 40%, since that row has to add up to 50. The next cell has to be 0.5, since the column has to add up to 0.6. And the last cell must be 0, right? Because this has to add up to 0.4, and this row has to add up to 0.5. Okay, let's start reading the answer choices now. Events A and B are independent. Okay. I don't know, but if that's true, the probability of A would equal the probability of A given B, and that'd have to equal the probability of A given not B. So we already know the probability of A is 0.5. What's the probability of A given B? Okay, so if B is the given condition, right, we can ignore those numbers, we could ignore those numbers. Okay, B occurs 60% of the time, and of that 60%, A will occur 10% of the time. So this is 0.1 out of 0.6, which is the same as 0.166. Okay, those are clearly not equal, so this is false. A and B are dependent. They are not independent. Okay. Right, choice B, events A and B are mutually exclusive. Okay, mutually exclusive means there's no overlap. Okay, but when we look at event A and we look at event B, we see that there is some overlap. 10% of the outcomes are in the overlap. Okay, so statement B is false. Okay. Choice C, either A or B always occurs. Right? That would be equivalent to saying the probability of A or B is equal to 1, 100%. Okay? All right, well, let's check. The probability of A or B, well, the probability of A is 0.5. The probability of B is 0.6. Again, we know there's overlap, so we need to adjust our answer for that. Right, subtract the 10% of the double counts, and hey, that does equal 100%. So that statement is true. You can also see here that there's a 0% chance of A and B both not happening, which means one or the other is always going to happen. Okay. Events A and B are complementary. Okay. So complementary means that their probabilities add up to 1, right? Like, the probability of rain and the probability of not rain, right? Those are complementary events, and they would always add up to 1. But these don't add up to 1, right? 0.5 and 0.6 don't just simply add up to 1. So that statement is false. Okay. E, none of the above is correct. Well, we've shown that statement C is correct. All right, so there it is.